Next type of sensor we'll be looking at is a style of hardness sensor. We call it the Schmidt hammer, or it's also called the Swiss hammer or the rebound hammer. Here's one of them here. And basically we've got this rod that can move in and out. I'll give a demonstration of it in a moment. And as we put that on our concrete surface, we can measure how much a hammer rebounds as it's pushed against an object from the force provided by the spring that's in there. Now, this was developed over 70 years ago by a Swiss engineer, Ernst Schmidt, so named after him. And it's a form of non-destructive test equipment. So we're not going to be destroying the thing that we're trying to measure in the process of measuring it. Typically, these are used to measure and characterize concrete structures, looking at to give an estimate of the strength of our concrete structure. If we open it up, the basic way they work, we have a spring inside here. We have a little hammer inside here as well. And as we push this against our spring, we're loading up a whole lot of force upon our spring. And at some point, the hammer will release a little mass. That mass will fly forward because the spring's pushing it forward. And it will hit the surface and the concrete surface. And then we'll measure the amount of rebound that we have pushing back against that spring. We have a little scale along here to measure that rebound on. And being a digital one, we can measure it and sample it digitally as well. Now, the harder our concrete, essentially, the more rebound that we'll get back against our spring. Now, these Schmidt hammers have a scale on them that we can use to characterize and convert our compressive strength from our rebound value to our compressive strength value in newtons. When we're using them, we want to make sure our surface is nice and clean, so we remove all the dust and things like that, and we push it down perpendicular to the surface that we're trying to measure. Now, when we're using these, we also want to test them against a known sample, and so we're provided with these little test anvils. Our test anvil will characterize this against a known quantity. And so we'll use our test anvil to characterize our device, and then we'll test it on multiple positions within our concrete. Now, we want to test it on multiple positions because sometimes locally we'll get slight variations in the hardness of our concrete. And so we might test it over a dozen different positions and then take an average of it to give us a better indication of what the true strength of the concrete's like. Having said that, this is still a rather indirect approach. And we call it an indirect approach because it's really measuring not the strength of the concrete all the way through, but it's measuring at various spots on the surface of the concrete. And so it's really best for giving a relative indication of strength between different locations rather than the actual true strength of the concrete, which we'd need to take a core sample, for example, and put in a UTM and crush it and work out destructively what the strength of that concrete was. Having said that, there are some testing standards associated with using our Schmidt hammer. Here's a cutaway version showing the process of our test, where we slowly push this down, our spring starts loading up until our hammer's disengaged, and then it makes that mass go forward, hit the front, and then rebounds back, and we measure how much is rebounded back. Now we have our Schmidt hammer, or our concrete rebound hammer. Here's our anvil that we use to test against. And so we can push that down, and you actually hear the spring go off, the hammer disengage, and it records. That's recording a value of 12 there. We can then do a similar measurement on the concrete. That's recorded the value of 16. And we can take multiple measurements. Normally we draw out a grid and take measurements so that we're not recording them all at the same place. That's recorded the value of 21. That's recorded the value of 19. So we're taking similar sort of measurements. This particular concrete here is fairly rough. There's a smoother section here. That's recorded the value of 25. That's recorded the value of 22. Here's some different concrete here where the aggregate's more exposed. That's recorded the value of 32, which suggests that it's a higher compressive strength in this concrete.